Good day, ladies and gentlemen. Today's topic is on how does the gold get into the rocks, with particular reference to our rocks at Kobada. I will talk about the structural geology in more detail and leave out the chemical side a little bit, as much as possible, but please bear with me. So we're talking about orogenic gold, mesothermal gold, and the word orogeny is in there, which is a mountain building process. And mountains are usually built when you have the collision of tectonic plates. At least one of these plates should be a continental plate. Current examples are the Andes, where the South American tectonic plate moves westwards onto the Nazca plate in the Pacific Ocean, the Himalayas, where the Indian subcontinent, a plate, moved from Africa into Asia and formed the Himalaya mountains, or the Alps, where Africa is moving northwards and not for the first time is closing up the Mediterranean. The previous sea that was in that position was called the tethys, and the tethys is now evident in marine sediments high up in the Alps. These are current examples for mountain building processes. Ancient ones are, for instance, the Abitibi in Canada, which many of you know, but also the Birimian in West Africa. We call them greenstone belts because they're highly deformed mountain building process results. Many of the rocks are volcanic, others are sedimentary. The volcanic rocks are very often basalt related, and the minerals have gone green. They have been chloratized, hence the greenstone belts. What all these orogenies have in common is a shortening of the lithologies. We are contracting, we're compressing, and we shorten the distance from the one end to the other by laying layers on top of each other, which we call tectonic naps. Very evident in the Alps. You can see that they're frequently with marine layers being high up on top of the Matterhorn. But deeper down, we can't push things on top of each other because of a space problem. So we squash things really, really tight. And we form isoclinal folds. And eventually you can't squash it any further. But the contraction is ongoing. The plates are still moving towards each other, and what you get eventually is an escape movement. This could be right lateral or left lateral, or dextral or sinistral. Now that we have these steep fractures, we can tap into the gold-bearing fluids. These fluids will ascend along fractures and faults, our shear zones, up to a level which we call the mesothermal window, which is roughly about 4 kilometers under the surface, bearing in mind this is the surface at the time of mineralization. In the case of the Birimian, 2.1 billion years ago. Faults are never straight. They curve, and if they move laterally, they create spaces along their strike. Where they create spaces at depth, there's a space problem. We're creating a low pressure zone. In other words, there's not a vacuum, but there's definitely a zone of low pressure which sucks the gold-bearing fluids into these spaces. Now that the fluids are there, the fault is also lubricated. So the fault is driving the fluid flow, and the fluids are driving the fault movement. At this depth, between 450 degrees Celsius and 300 degrees Celsius, this is where the gold precipitates. And where does it precipitate? It precipitates when the chemistry is right, but also the kinematics. As long as fluids flow, precipitation is rather difficult. Compare that to a river that freezes up. If it flows at a high rapid speed, it is much more difficult to freeze it, whereas a standing lake freezes easily. Very similar with the gold-bearing fluids. We are creating a fracture system, a fracture regime with a movement. and a sinistral or left-handed movement would create different fractures or different orientations of fractures to a right-handed or dextral movement. We create a lot of radial shears and extensional veins, and these tend to open up. Fluids can go into these fractures, and because these fractures end, they're not continuous over kilometers, the movement of the fluid has stopped, and now the gold can precipitate together with the quartz, which crystallizes in those cracks. Thank you.